The UJ-22 drone has quickly risen to prominence as a game-changing weapon in the Russia-Ukraine conflict, posing an unparalleled threat to Russian military operations. Designed by Ukrainian forces, this unmanned aerial vehicle has repeatedly showcased its ability to evade advanced Russian air defenses and deliver pinpoint strikes on high-value targets deep within enemy lines. Its combat effectiveness raises serious questions about the future of warfare and the vulnerabilities of even the most sophisticated military powers. But what makes the UJ-22 so effective, and why has Russia struggled to neutralize this threat? Does this signify a fundamental shift in modern warfare, where smaller, smarter technologies can outmaneuver traditional defense systems? Join us as we delve into the technical brilliance of the UJ-22 and the strategic implications it carries for the battlefield and beyond. Technical specifications reveal why the UJ-22 drone presents significant challenges for air defense systems. The aircraft features a conventional light aircraft layout with a front-mounted tractor propeller and straightforward wing design. Specifically, the drone measures 3.7 meters in length with a wingspan of 4.2 meters. The UJ-22 drone stands out for its exceptional design, which emphasizes both operational flexibility and durability, making it a highly versatile tool in modern warfare. One of its most remarkable features is its ability to adapt to extreme environmental conditions, functioning seamlessly in temperatures ranging from as low as 40 degrees to as high as 50 degrees. This adaptability ensures reliable performance across a wide range of challenging terrains and climates. Furthermore, its construction supports takeoff and landing on various types of surfaces, requiring only a minimal runway length, which enhances its deployment versatility in diverse operational scenarios. Equally impressive are the drone's performance specifications and payload capabilities. The UJ-22 achieves cruise speeds of 120 km/h, can accelerate up to a maximum speed of 160 km/h, and maintains a minimum operational speed of 90 km/h. These speed ranges allow it to adapt to different mission requirements, whether they demand rapid deployment or controlled maneuverability. The drone is capable of carrying a payload of up to 20 kilograms, allowing it to transport a variety of munitions tailored to specific operational needs. For instance, it can be equipped with 4 82mm mortar mines or 6 P-7VM anti-tank rocket launcher munitions, significantly enhancing its strike capabilities. This combination of adaptability, speed, and payload versatility positions the UJ-22 as a critical asset on the battlefield, capable of delivering precise and impactful strikes even in the most demanding conditions. The drone's navigation capabilities are particularly sophisticated. The UJ-22 operates effectively at altitudes between 50 and 6,000 meters. Moreover, the system features dual operational ranges, 100 kilometers under direct control and an impressive 800 kilometers in autonomous mode. The UJ-22 drone integrates cutting-edge communication systems designed to ensure secure and reliable data transmission, a critical feature for operations in contested environments. These systems utilize encrypted data channels, safeguarding the drone's communication from potential interception or disruption by adversaries. This advanced communication infrastructure supports a robust control architecture that offers unparalleled flexibility in operational deployment. The drone's control system provides 3 distinct operational modes to suit varying mission requirements. The first mode, automatic flight, enables the UJ-22 to navigate along pre-programmed paths with precision, minimizing the need for direct operator intervention. This mode is ideal for missions requiring long-range reconnaissance or pre-planned strikes. The second mode, semi-automatic operation, allows operators to oversee the drone's mission while retaining the ability to make real-time adjustments as necessary, combining the advantages of autonomy with human oversight. Finally, the full manual control mode gives operators complete authority over the drone's movements and actions, offering maximum responsiveness to dynamic and rapidly changing battlefield conditions. The UJ-22's electronic warfare resistance is enhanced through its ability to operate without GPS signals. Furthermore, the communication system employs automatic tracking antenna systems with redundant data channels, ensuring reliable operation in adverse conditions. The ground control station maintains 24/7 operational capability, requiring a crew of 4 personnel for mission execution. The combat capabilities of the UJ-22 drone demonstrate remarkable versatility in modern warfare operations. Indeed, this unmanned system excels in multiple combat roles through its advanced features and adaptable design. The UJ-22's remote piloting system enables precise control up to 100 kilometers from the command center. Nevertheless, the drone can operate autonomously beyond this range using pre-programmed coordinates and elevation data. The control system requires only 2 operators, a pilot and a payload specialist, enabling efficient mission execution with minimal personnel. The UJ-22 demonstrates exceptional environmental adaptability, operating effectively in various conditions. The system maintains full functionality in both visual and adverse weather situations. Undoubtedly, this capability ensures consistent mission execution regardless of environmental challenges. The UJ-22 drone exemplifies exceptional operational versatility, capable of undertaking a wide array of mission types, each tailored to address specific tactical and strategic requirements. Its design and technological advancements enable it to excel in intelligence gathering, combat operations, and search and rescue missions, making it an indispensable tool in modern military engagements. For intelligence gathering, the UJ-22 is equipped to capture and transmit high-resolution imagery in real time, delivering photo transmissions with an impressive resolution of 5 cm per pixel. This capability allows for detailed reconnaissance, enabling military commanders to make informed decisions with precise visual data from the battlefield. In combat operations, the drone demonstrates remarkable precision in striking targets. From an altitude of 700 meters, it can achieve strike accuracy within a 10-meter radius, effectively neutralizing high-value targets while minimizing collateral damage. This level of precision underscores its value as a weapon system capable of surgical strikes in complex operational scenarios. Search and rescue missions further highlight the UJ-22's adaptability, as it is engineered to perform reliably in extreme environmental conditions. Its ability to endure harsh weather and navigate challenging terrains ensures its effectiveness in critical life-saving operations where timing and reliability are paramount. The drone's operational features are equally noteworthy. It boasts a flight endurance of up to 6 hours, even under extreme weather conditions, allowing for sustained missions without interruption. This endurance is complemented by its capability to return unused ammunition safely, reducing risks associated with unexploded ordnance. Additionally, the UJ-22 is equipped with an advanced inertial navigation system, enabling it to operate effectively in GPS-denied environments. This system ensures accurate navigation and mission execution, even in scenarios where traditional satellite navigation systems are compromised. The UJ-22's electronic warfare resistance is enhanced through the Zexon inertial system, accordingly allowing navigation without GPS dependence. Similarly, the drone's semi-automatic takeoff and landing capabilities require minimal runway length, theoretically 100 meters. Though practical experience shows successful operations from 50 to 60-meter strips. The system's combat effectiveness is further enhanced by its ability to operate in electronic countermeasure environments. This capability, combined with its multi-mode control options, enables the UJ-22 to execute various tactical missions, from neutral reconnaissance to offensive strikes. Real-time image transmission capabilities provide operators with detailed terrain analysis, offering strategic advantages in mission planning and execution. The drone's ability to maintain controlled flight while carrying various payload configurations makes it an exceptionally versatile platform for multiple combat scenarios. Recent developments in the Russia-Ukraine war update today highlight the UJ-22 drone's exceptional ability to breach sophisticated air defense networks. The aircraft's success in penetrating heavily defended airspace stems from 3 critical capabilities. The UJ-22 drone's relatively compact dimensions make it challenging for radar systems to detect. With a wingspan of 4.2 meters and a length of 3.7 meters, the aircraft presents a minimal radar profile. Subsequently, Russian air defense systems, primarily designed to intercept larger aircraft and missiles with substantial radar cross-sections, struggle to track these smaller targets effectively. The drone excels at nap-of-Earth flight operations, therefore avoiding radar detection through terrain masking techniques. Notable capabilities include operation at altitudes as low as 50 meters above ground level, visual terrain avoidance for enhanced survivability, and maximum speed of 160 kilometers per hour for tactical flexibility. The UJ-22 drone is equipped with state-of-the-art electronic warfare protection systems that significantly enhance its resilience against Russian countermeasures. This advanced technological framework ensures that the drone can maintain its operational effectiveness even in highly contested environments where electronic interference and jamming are prevalent. At the core of its defensive suite is a highly sophisticated flight control system designed to navigate and operate seamlessly in adverse conditions. One of its standout features is the incorporation of the XN's inertial navigation system, which enables the UJ-22 to function efficiently in GPS-denied environments. This capability is critical for maintaining mission integrity in scenarios where satellite signals may be obstructed or actively disrupted by enemy electronic warfare tactics. The inertial navigation system provides accurate positional awareness, allowing the drone to stay on course and achieve its objectives, even without external guidance. The control architecture of the UJ-22 further underscores its versatility and adaptability. Operators can choose from 3 distinct modes of operation depending on the mission's demands. In automatic mode, the drone can follow pre-programmed flight paths with precision, requiring minimal operator intervention. Semi-automatic mode offers a balance between autonomy and human oversight, allowing operators to make adjustments in real time. For missions that demand immediate and responsive control, the manual mode provides operators with full authority over the drone's movements and actions, ensuring optimal performance in dynamic and unpredictable environments. Communication is another area where the UJ-22 excels, thanks to its advanced encrypted data channels. These channels ensure secure and uninterrupted communication between the drone and its operators, even in the face of attempts to intercept or disrupt transmissions. Additionally, redundant communication systems provide an added layer of reliability, ensuring that the drone remains connected and operational under the most challenging conditions. The drone's effectiveness against Russian defenses is primarily demonstrated by successful penetrations of Moscow's air defense network. Russian military experts have acknowledged their limited capabilities in countering these aircraft, noting that conventional air defense systems lack effective means to stop them. The UJ-22 success rate has prompted Russian authorities to implement additional defensive measures. However, these efforts have shown limited effectiveness. The drone's ability to operate in adverse weather conditions and electronic countermeasure environments has established it as a persistent threat to Russian military assets. Russian countermeasure attempts include deploying various jamming systems such as the Borisogledsk-2 and Krasokov-4. Nonetheless, the UJ-22's advanced navigation systems and multiple control modes enable it to maintain operational effectiveness despite these defensive measures. The combination of these capabilities enables the UJ-22 to consistently breach Russian air defenses, particularly when conducting precision strikes against stationary targets. This operational success has led to increased deployment of these drones for long-range missions, notably affecting critical infrastructure and military installations within Russian territory. Ukrainian military operations have demonstrated the UJ-22 drone's exceptional strike capabilities through numerous successful missions deep within Russian territory. The aircraft's operational reach extends beyond 1,300 kilometers behind Russian lines, marking these attacks as some of the most extensive penetrations of Russian airspace. In early April 2024, UJ-22 drones executed precision strikes against 2 strategic targets in Tatarstan. The primary targets included the Taneko oil refinery in Nizhnekamsk's industrial zone and the Shahed 136 drone production facility in Yelabuga. Initially, the strikes resulted in significant damage to both facilities, with one UJ-22 hitting a dormitory housing the student workforce at the Yelabuga plant. The attack on the Taneko refinery left behind physical evidence, including recovered drone components. The UJ-22 drone strikes have had a profound and far-reaching impact across various strategic and operational sectors, significantly undermining the enemy's capabilities. These precision attacks have targeted high-value assets and inflicted damage on critical infrastructure, disrupting operations and forcing adversaries to redirect resources toward mitigating the fallout. One of the sectors most severely affected has been the oil industry. Strikes on key oil refineries have resulted in a dramatic reduction in industrial capacity, with output reportedly decreasing by 14%. This disruption not only impacts the immediate availability of energy resources, but also has a cascading effect on the logistical and operational efficiency of military and civilian activities reliant on these supplies. The drone's effectiveness extends to military installations as well. At the Moravsk Aerodrome, a strategic airfield, 6 aircraft were destroyed in a single operation. This loss represents a significant blow to the adversary's air power, reducing their operational readiness and limiting their ability to project force effectively. Such precision strikes on critical military assets compel adversaries to rethink their defensive strategies and allocate additional resources to protect other vulnerable sites. At the same Morovosk aerodrome, at least 20 military personnel were reported as casualties. This not only diminishes the adversary's manpower, but also lowers morale among surviving troops, amplifying the psychological impact of these strikes. The loss of skilled personnel, particularly in roles requiring specialized training, further compounds the challenges faced by the adversary in maintaining their operational tempo. Notably, the strikes have affected critical infrastructure, primarily targeting military equipment storage facilities, industrial complexes, and strategic military bases. The effectiveness of UJ-22 drone operations is evidenced by their consistent ability to penetrate Russian defenses. Between May and July, the number of successful Kamikaze drone strikes in Russia doubled compared to the entire previous year. The operational success is attributed to several factors, such as the effective use of terrain following flight paths, strategic target selection, and coordinated mission planning. The UJ-22's mission success is essentially demonstrated through its ability to consistently reach targets at extreme ranges. For instance, during the Tatarstan operation, multiple drones successfully traversed more than 1,200 kilometers of heavily defended airspace. These achievements have prompted Ukrainian military intelligence to announce that such operations will continue with increasing range capabilities. The strategic impact of these missions extends beyond physical damage. Russian regions previously considered secure have experienced disruptions to daily operations, including airport closures and emergency evacuations. Primarily, these strikes have achieved their objectives of degrading Russian military infrastructure while demonstrating Ukraine's expanding strike capabilities. Cost analysis reveals the economic advantages of the UJ-22 drone in modern warfare operations. The financial implications of deploying these unmanned systems demonstrate significant advantages over conventional military hardware. A thorough cost analysis reveals significant distinctions between the UJ-22 drone and more traditional weapon systems, highlighting its cost-effectiveness as a modern combat solution. The production costs of the UJ-22 vary depending on its specific configuration, but even in its basic setup, the financial outlay remains remarkably low compared to other systems. The UJ-22 in its standard configuration is estimated to cost approximately $106,500, making it a highly economical option for delivering precision strikes and supporting a variety of tactical operations. In stark contrast, traditional cruise missiles, often used for similar purposes, typically exceed $5 million per unit. This vast difference underscores the economic advantage of employing drones like the UJ-22 in prolonged or high-frequency conflicts, where the cost per engagement is a critical factor. Even when compared to other drones, such as the Shahed-136, which is priced at roughly $100,000, the UJ-22 remains competitive. While the price points are comparable, the UJ-22's advanced capabilities, including precision targeting, enhanced navigation systems, and versatility, provide added value that justifies its slightly higher cost. The UJ-22's cost-effectiveness becomes apparent through its operational success rate. Essentially, the drone's production costs remain significantly lower than comparable weapon systems, altogether making it an economically viable option for military operations. The operational benefits of the UJ-22 extend well beyond its affordable production costs, offering substantial savings in several key areas. Military analysts emphasize its ability to reduce overall personnel requirements, as only 4 crew members are needed to manage its operations efficiently. This streamlined approach not only cuts labor costs but also simplifies logistics and training. Additionally, the UJ-22 requires minimal infrastructure for deployment, allowing it to operate from a variety of locations without the need for extensive or costly facilities. This flexibility reduces the financial and logistical burden typically associated with setting up and maintaining operational bases for more traditional systems. The drone's straightforward design architecture further contributes to its cost-effectiveness by lowering maintenance expenses. Its simplicity translates to easier repairs, fewer specialized parts, and reduced downtime, ensuring that it remains mission-ready without incurring high operational costs. The cost-to-kill ratio analysis demonstrates the UJ-22's efficiency. Generally, modern drone systems achieve a success rate between 35% to 40% in hitting their targets, making them a cost-effective choice for precision strikes. The UJ-22 drone's impressive resource efficiency is a direct result of its innovative production methodology and streamlined operational characteristics. Ukrainian manufacturers have developed an advanced production network designed to maximize efficiency while maintaining high output quality. This network leverages distributed manufacturing where multiple production facilities are strategically located across different regions. This approach not only ensures continuity in case of disruptions, but also allows for rapid scaling of production to meet varying demand levels. The system is designed with flexibility in mind, enabling adjustments in production volumes to suit immediate operational needs. Another cornerstone of the UJ-22's resource efficiency is its focus on component optimization. By incorporating commercially available parts, the manufacturing process avoids reliance on bespoke or rare materials, significantly reducing costs and production times. Simplified assembly processes further enhance efficiency, allowing for faster production cycles and reducing the need for highly specialized labor. Additionally, the use of standardized components ensures compatibility and interchangeability, streamlining maintenance and repair efforts in the field. The manufacturing approach enables quick production scaling, with some Ukrainian facilities producing up to 45,000 drones monthly. Overall, this production capacity ensures a steady supply of units while maintaining cost efficiency. The economic impact becomes more apparent when considering operational sustainability. The UJ-22's ability to operate in GPS-denied environments reduces the need for expensive supporting systems. Additionally, its multi-role capabilities allow military planners to allocate resources more efficiently across different mission types. In terms of battlefield economics, the UJ-22 demonstrates superior cost efficiency compared to traditional artillery. A single artillery shell often costs more than an entire drone system, while offering less precision and requiring more logistical support. Systematic assessment of battlefield operations reveals the extensive impact of UJ-22 drone strikes on Russian military capabilities. The unmanned aircraft's precision targeting has resulted in substantial losses across multiple sectors of Russian military infrastructure. The UJ-22 drone's effectiveness against military targets is evidenced by recent operations. At the Morovsk aerodrome, a single strike destroyed 6 aircraft and caused casualties among 20 military personnel. Essential military assets targeted include strategic bombers and surveillance aircraft, air defense installations, and military supply depots. A notable operation in Zhonkoy, Crimea, eliminated critical air defense components, including 4 S-400 launchers, 3 radar stations, 1 air defense control center, and multiple airspace surveillance systems. The impact on Russian infrastructure has been particularly severe, primarily targeting energy and military-industrial facilities. Between January and April 2024, Ukrainian forces executed a series of successful operations, targeting a total of 29 oil, gas, and metallurgical facilities. In addition to the damage inflicted on energy infrastructure, Ukrainian forces have also focused on military and defense facilities, striking 19 key sites during the same period. Notably, these strikes have diminished Russian oil refining capacity by approximately 14%. The attacks have extended to previously secure regions, with successful strikes recorded at distances exceeding 1,300 kilometers from Ukrainian territory. The operational impact of the UJ-22 drone goes far beyond the immediate physical destruction it causes, creating a force multiplication effect that significantly alters the dynamics of military engagements. This impact is felt through a variety of strategic advantages and operational consequences that stretch across the battlefield. One of the most significant advantages is the drone's extended strike range, which allows it to carry out operations up to 2,000 kilometers from its launch point. This long-range capability enables Ukrainian forces to engage targets deep within enemy territory, disrupting critical infrastructure and strategic assets from afar. The resource allocation required to counter the UJ-22 has also been a considerable strain on Russian forces. The drone's threat has forced the deployment of over 50 Panzer air defense systems to protect key assets from its strikes. This diversion of resources highlights the growing challenge Russian forces face in managing their air defense capabilities, as these systems are stretched thin across multiple fronts. Additionally, the UJ-22's persistent presence has led to defensive disruption, compelling the relocation of air defense assets to more vulnerable positions. This not only weakens the overall defense posture but also exposes other high-priority targets to further strikes, creating a ripple effect throughout the enemy's strategic planning. Currently, Russian military planners face unprecedented challenges in protecting their assets. The necessity to defend against UJ-22 strikes has prompted the installation of electronic warfare systems at industrial facilities, primarily at the owner's expense. The cumulative effect of these operations has prompted significant operational changes in Russian military deployment patterns. Military equipment, notably tanks and heavy machinery, has been forced to operate several kilometers further from the front lines. This tactical adjustment has substantially reduced Russian forces' offensive capabilities. The systematic targeting of strategic assets by UJ-22 drones has created what military analysts term a thousand-cut strategy. This approach has proven particularly effective in degrading Russian military infrastructure, disrupting supply chains, forcing resource reallocation, and limiting operational flexibility. The battlefield impact is ultimately reflected in the expanding geography of successful strikes. These operations have demonstrated the UJ-22's capability to penetrate sophisticated air defense networks while maintaining operational effectiveness against both static and mobile targets. Russian military forces face mounting difficulties in developing effective countermeasures against the UJ-22 drone. Their traditional air defense systems, primarily designed for larger aircraft and missiles, struggle to adapt to this emerging threat. Russian air defense systems have proven to be highly vulnerable to the capabilities of the UJ-22 drone. Andriy Gurylev, a deputy in the State Duma, openly acknowledged that conventional anti-aircraft systems are ill-equipped to effectively counter these unmanned aerial vehicles. The shortcomings of these defense systems become especially evident in several critical areas. One of the most glaring issues is the inadequate coverage of critical infrastructure, leaving key targets exposed to drone strikes. Additionally, Russian air defense systems struggle to defend against low-flying targets, which is a hallmark of the UJ-22's operational approach. This makes it difficult for defense systems to track and neutralize drones before they reach their intended targets. Furthermore, the rapid response capabilities of Russian air defense are insufficient to deal with the speed and precision of the UJ-22, which can strike swiftly and with little warning. Russian forces have attempted to address these shortcomings by introducing the Yak-52B2 counter-drone variant. Essentially, this aircraft carries specialized radar and electronic warfare systems for drone detection and suppression. Nevertheless, these adaptations have shown limited success against the UJ-22's advanced features. The technical challenges in detecting UJ-22 drones stem from their unique operational characteristics. These unmanned systems operate at altitudes between 56,000 meters, markedly complicating detection efforts. A detailed analysis of detection challenges highlights the limitations of various systems when attempting to identify the UJ-22 drone. Traditional radar systems struggle to detect the drone effectively due to its small cross-section, which reduces its radar signature and makes it harder to track at long distances. Infrared tracking also proves to be largely ineffective, as the UJ-22 generates minimal heat, making it difficult to detect using thermal imaging. Acoustic detection systems, on the other hand, are only effective at close range, limiting their usefulness in identifying the drone from a distance. The Russian military has straightaway recognized that these drones present at apical targets, small, low-flying, with low radar visibility. Whether using conventional or modified detection systems, Russian forces struggle to maintain consistent tracking capabilities. The deployment of countermeasures against UJ-22 drones has imposed substantial resource requirements on Russian forces. Namely, the military has been compelled to deploy over 50 Panzer air defense systems, install electronic warfare devices at industrial facilities, and relocate air defense assets from other strategic locations. The economic impact becomes apparent as Russian oil companies and strategic enterprises must invest in their own electronic warfare devices. Soon, this requirement extended to dozens of potentially significant objects, creating an ongoing drain on resources. The effectiveness of electronic warfare, referred to as EW for short, systems, although initially considered promising, has shown mixed results. Russian forces employ various jamming frequencies, primarily affecting drone control signals. Unless operators adapt quickly, these measures can disrupt drone operations. Until recently, early versions of Ukrainian long-range drones were vulnerable to Russian electronic warfare systems. The situation has compelled Russian military planners to implement a layered defense approach. Infantry units now deploy smaller UBLU devices and drone guns to protect their positions. The 59th Brigade's experience highlights the ongoing challenges. Their homemade EW system and portable devices became less effective as Ukrainian UAVs adapted to different frequencies. The resource allocation challenge extends beyond equipment. Russian forces must maintain continuous counter-drone operations across an expanding battlefield. The necessity to protect both military and civilian infrastructure has created unprecedented demands on personnel and material resources. This operational strain manifests in increased maintenance requirements, extended personnel training needs, and continuous system upgrades. The effectiveness of these countermeasures varies significantly. While some systems achieve limited success in specific scenarios, the overall impact remains insufficient to neutralize the UJ-22 threat. The Russian military's struggle to develop effective countermeasures continues to influence strategic planning and resource allocation across their entire defensive infrastructure. Ukrainian military industry advances toward extensive expansion of its unmanned aerial vehicle capabilities. The government has set an ambitious target to manufacture 1 million FPV drones in 2024, marking a substantial escalation in production capacity. The development roadmap for the UJ-22 platform emphasizes artificial intelligence integration. Currently, both Ukraine and Russia are working on AI-guided drones, with initial implementations already visible in select units. The primary improvements focus on enhanced target identification systems, advanced autonomous navigation capabilities, and improved electronic warfare resistance. These technological advancements require substantial development before widespread deployment. Essentially, the integration of AI systems represents a fundamental shift in drone warfare capabilities, with Ukrainian manufacturers prioritizing this development path. The Ukrainian defense industry has significantly broadened its range of unmanned aerial vehicles, expanding beyond the UJ-22 to introduce several advanced platforms. Among these new additions are the UJ-23 Topaz, UJ-31 Zliva, and UJ-32 Lastivka, each designed with specialized capabilities to enhance operational effectiveness. The UJ-23 Topaz is a multi-purpose jet UAV, although its exact range remains classified. The UJ-31 Zliva and UJ-32 Lastivka are both loitering munitions, each offering an extended operational range. These new UAV variants are equipped with several advanced features, significantly improving their battlefield performance. They are designed for all-weather operations, ensuring reliability in diverse environmental conditions. Additionally, they possess enhanced resistance to electronic countermeasures, which helps them maintain operational effectiveness in environments where adversaries employ jamming or other disruptive technologies. The target acquisition systems have also been upgraded, enabling these drones to more accurately identify and engage targets. The development of these platforms primarily targets both stationary ground and waterborne objectives, complementing the capabilities of the existing UJ-22. These new variants provide more specialized mission profiles, broadening the scope of Ukraine's unmanned aerial vehicle fleet and enhancing its capacity to address various tactical and strategic challenges on the battlefield. Future iterations of Ukrainian drones aim for substantial improvements in operational range and effectiveness. German media sources report the development of the Sokol 3000, with a projected range of up to 3,300 kilometers. Currently, several other companies are working on drones capable of reaching targets at least 2,000 kilometers away. The improved capabilities of the UJ-22 and its variants extend across a wide range of operational aspects, enhancing mission planning and execution. The advanced mission planning software enables flight task programming with greater precision, incorporating sophisticated coordinate systems for more accurate navigation. Operators can switch seamlessly between manual and automatic modes, offering flexibility in mission control. Additionally, the system has improved functionality for marking no-fly zones, which enhances the safety of operations by ensuring that drone movements avoid restricted areas. The ability to make in-flight program adjustments adds further versatility, while enhanced alternate landing options provide greater operational security in the event of unforeseen circumstances. A standout feature of the UJ-22's mission planning is the Daedalus software suite, which introduces a range of advanced tools to optimize mission execution. It is compatible with the WEG's 84 reference system, ensuring precise geolocation and navigation. The software also supports multiple coordinate systems, allowing operators to work within different geospatial frameworks as needed. Furthermore, advanced flight planning tools and comprehensive no-fly zone management capabilities significantly enhance the drone's operational flexibility, enabling more effective deployment in diverse mission scenarios. Ukrainian manufacturers place a strong emphasis on quality, ensuring that the platform combines operational simplicity with high reliability. These drones are designed to be multifunctional and capable of carrying out a wide variety of mission profiles. Additionally, the integration of enhanced safety features ensures that these systems are not only effective but also secure and dependable in critical operational environments. The development strategy focuses on cost-effective production methods, primarily because drones offer significant advantages over traditional weapon systems. For example, an FEV drone costs less than a single artillery shell while providing superior accuracy. The industry's expansion is reflected in the growing number of companies involved in unmanned systems manufacturing. Approximately 200 companies now participate in this sector, with 50 already authorized to supply military products. This represents a 12-fold increase from the previous year. Looking ahead, Ukrainian drone manufacturers concentrate on improved propulsion systems, extended flight capabilities, enhanced fuel tank capacity, and advanced aerodynamic designs. These developments aim to support Ukraine's strategy of striking targets deep inside Russian territory, compensating for limitations in long-range missile capabilities. The focus remains on creating systems that combine operational effectiveness with production efficiency. The strategic focus on unmanned systems in Ukraine's defense industry is driven by several key considerations. First, these systems are significantly less expensive to produce compared to traditional weaponry, making them a cost-effective solution for sustained military engagements. The manufacturing process for unmanned systems is also more streamlined, leveraging the technological expertise of NATO countries, which allows for efficient production without relying on highly specialized or costly components. Furthermore, the emphasis on quantity over individual unit quality allows for the production of a larger number of systems at a lower cost, enabling more widespread deployment. This strategy is particularly valuable in modern warfare, where having multiple, versatile assets in the field can be more effective than relying on fewer, higher-cost units. As a result, the focus on unmanned systems not only enhances operational flexibility but also ensures that Ukraine can maintain a significant technological and tactical advantage through sheer volume and efficiency. Ukrainian defense industry figures acknowledge that while current AI technology requires further refinement, these systems will likely become central to future drone warfare. The ongoing development of these capabilities represents a significant shift in military technology, with implications for future conflict scenarios. The UJ-22 drone has proven to be a game-changer in modern warfare, with its advanced capabilities and cost-effectiveness posing a significant challenge to Russian defense systems. Its ability to strike targets deep within Russian territory highlights its operational success, while its lower production costs make it a powerful yet affordable asset. Despite the mounting losses, Russian forces struggle to counter the UJ-22's effectiveness, and military planners must make tough decisions on resource allocation. As Ukrainian manufacturers continue to innovate, the UJ-22 and its future variants are set to play a crucial role in shaping the future of warfare. What do you think about the impact of drones like the UJ-22 on future conflicts? Share your thoughts in the comments below. If you enjoyed this video, don't forget to like and subscribe to our channel for more updates. Thank you for watching.